Hey guys, welcome back. In this video, we'll mainly talk about one of the 5G concepts that is analog beamforming. Let me talk about analog beamforming from all these aspects. So, in the earlier videos, I was talking about the increase in the bandwidth for 5G to give better data rates, and then with this we had challenges, and for that I was mentioning that we had moved to millimeter waves, right? So when we moved to millimeter waves, I was mentioning a couple of challenges. In that, I was mainly mentioning about increase in the path loss because of higher frequency. So with that, I was mentioning that the new technology is introduced in 5G. So let me talk about it. That is with respect to analog beamforming. So I will try to get into some more details here. So when we entered into millimeter wave, okay. So I was mainly telling that the center frequency has been increased. So with that, the path loss, which is directly related to frequency, that is also increased to a greater extent. So let us take 4G, okay. Let's say we have antenna here. Let me take two antenna. So let's say I'm going for 4G. So let's say with these two antennas, let's say the beam formed in case of 4G is something like this. So let's say something like this. Okay, let me write it. Uh, yeah, something like this. Let's say this is a wider beam. Okay, and also it has traveled around this much distance. Okay, let's say now I have got two UVs. Let's say this is UV number one, and let's say this is another UV number two. So in that case, what is happening? Both the UVs are addressed with a single beam. But when we are addressing both the UVs with a single beam, we need to have orthogonality, right? Because both the UVs are getting the similar signal. Somewhere we should have the orthogonality. So orthogonality, how can we achieve? So it could be time division multiplexing. So maybe at a different times we can try to address these two UVs. That is one thing. Uh, or let's say on particular slot we can assign resources to UV number one, and on some other slot or some other time slot we can assign resources to UV number two. But if we want to address both of the UVs in the same slot, then we are left out with two more concept, that is FDM, frequency division multiplexing. Basically, both of these UVs will be allocated to different subcarriers which are orthogonal to each other. So there won't be any overlapping subcarriers. So that is taken care with this, and then the another one is CDM, code division multiplexing. Some of the control channels are actually are using CDM, code division multiplexing. If they're even using same time and same frequency, basically same frequency means same subcarrier, they can be made orthogonal by using different codes, maybe orthogonal cover code, like that. So that's how it was done in case of 4G. Okay, this was done in case of 4G. Now we are in 5G, and let's say we are talking about millimeter waves. What is going to happen? So let me take the same antennas and and let's say I am going to transmit with the same power. Then in case of 5G, because of this millimeter wave, what is happening? Um, you know, because of high path loss, the beam would be, let's say, something like this. Okay, the beam did not travel for the longer distance, that is first point, and there is a huge path loss. And if you see with this beam, we were not in a position to even address any of the UVs. All right, so that is when a new technology is introduced, that is nothing but analog beamforming. In analog beamforming, what are we going to do? Yeah, there is a beamforming series which I have already started. I have covered many basic concepts there. Soon I will enter into the beamforming concepts, in case of in case of 5G. Okay, please, you can watch that one. So in case of analog beamforming, we will be using phase shifters. So at each of these antennas, we will be using phase shifters, using which and even okay, let me write it here. In case of analog beamforming, uh, so we are trying. First thing is we would be trying to use more number of antennas. Okay, large number of antenna array. Then each of these antennas have the phase shifters, okay, so that the beam can be formed in a required direction. Now with this, what we can ensure is that, let's say, okay, let's say in case of 4G, the beam is something like this. Now with 5G, okay, let me write the other one as well. It did not travel for a longer distance. Now with beam forming, okay, these two are, I would say, non-beam forming when it was non-beam forming case. But with the beam forming case, let me write it. So we can form a narrow beam and that can travel for a longer distance. Okay, basically, whatever the energy or power is constant in all of these three things. Whatever the power that was accumulated in this beam, now that is compressed, and the similar power can be seen in this, but the power is much more focused, and the directivity has increased, and then we see that it has traveled a longer distance. With this, what I would say is, still, there was UV 1 year, UV another, UV 2 year, right? Still we are not able to actually address both the UVs. So that is when, with respect to analog beamforming, multiple concepts related to this is will be used in 5G. So one is the dynamic beamforming. Okay, so under dynamic beamforming, I would say dynamic beamforming, that is like beam steering. Okay, first, since we don't know, right, where is the UV position and all, first we need to steer the beam from different angles. So let me, okay, so we need to steer the beams, okay, in these angles. Then we get to know, okay, the third beam, in the third beam we will have this UV. Okay, and something like that, we also get to know that, let's say, the beam number 7 has this UV. Now once beam steering is done, then we need to do beam switching. Right, now we know which beam has got which from which beam we can address the UVs. So accordingly, when we want to transmit the data, we can directly use beam 3 to address UV number 1, and we can directly use beam we can switch to beam number 7 to send data to UV number 2. So by that way we can go for beam switching. Or if we have the flexibility, or if the design is done such a way that we can have multiple beams at the same time, then we can even address both UV number 1 and UV number 2 in one shot using the beam 3 and 7. So all of these concepts will be covered in beamforming series, series number 9. Okay, you can go through that playlist. So I hope you got the concept with respect to analog beamforming, how things are done. um, so now, when we got to know, right, like we got to know that with analog beamforming, the advantage is that we can transmit the beam for a longer distance. But again, here the disadvantage is that we will be not able to cover multiple UVs in the single beam, so we have to do beam switching, beam steering and all. But there is apart from these advantages, there is one more problem, that is, let's say, um, you have got, let's say, one base station. So let's say this is performing the beam forming, and it has got a very narrow beam, let's say. Okay, then earlier when we had the wider beam, okay, when we had the wider beam, the thing is that even we had an obstacle. Let's say here, I got an obstacle which is a building. This is a building. Then this wider beam, was let's say there is a let's say there is a uh, receiver here. Okay, let's say the receiver is here. So with the wider beam, still the signal could be addressed from other directions, right? But with this narrow beam, okay, with this narrow beam, since it is not going, I mean, it is focused and it is not spread in many directions. So the thing is that it will hit the building, and we see in this case that the signal is not reached to this particular UV. This is one disadvantage. So there would be a lot of obstacles to this narrow beam, and we will see that it will not reach to many remote areas. In that case, what should be done? So for that, another new technology or new scheme has been proposed in 5G. This also will come in the upcoming videos. But please note down this disadvantage as of now, or challenge as of now. Okay, I hope with this you got the clarity with respect to all the advantages and disadvantages in case of analog beamforming, why we had to implement, why we had to introduce this analog beamforming technology in 5G. That also you got to know. So then, with respect to 3GPP, okay, for 3GPP concepts, or how it should be implemented, how it should be implemented in case of beamforming, that I will come in the future videos, or in the beamforming series. Okay. With this, I will wind up the video. Thank you very much. Have a great day. Bye bye. Please do subscribe to the channel.